All right, what we're going to be focusing on tonight is something called the activity series. And the activity series is a special list of elements in order for single replacement reactions only. So this is a chart that you are only going to use for single replacement reactions. So what is it? It really determines whether one element will be able to displace or kick out an element that's in the compound for a single replacement reaction. Basically, these elements have a hierarchy. Okay, so the higher up the metals are, the more active they are, meaning the more reactive they will be, meaning that they will be able to kick out anybody below them who's involved in a compound. Now, if you think back to elements, every element wants to be a part of or have an octet. And in order to do that, an individual element by itself has to be a part of a compound. Why? Because in a compound, they can get those charges, which means that they gain or lose the right amount of electrons in order to get their octet. When you look at these guys, lithium on this particular list wants to be a part of a compound and wants to get that octet more than anybody else below it. Okay, so that's why, so lithium will be able to kick out anybody below it and be able to be a part of a compound if it's reacting with one. If it's lower than lithium, and it's an individual element trying to kick out lithium, it will not be able to do that, and therefore no reaction occurs. So not every single replacement reaction occurs. The only time it occurs is when the element by itself is higher up on the activity series than the element it is trying to kick out. So let's try to see if these reactions occur. So what we're going to do is identify that it's a single replacement. How do I do that? It's got an element plus a compound. Now the element by itself will try to kick out its like. So Ag is a metal, so we'll try to kick out the metal that's in the compound, which would be Cu. So all you have to do is go look at Ag on the activity series, which is a metal, and Ag is here, and Cu is right above it. So because Ag is lower than Cu, it will not be able to kick it out, so this reaction will not occur. Okay, looking at the next guy, the element by itself, so zinc, has to be higher than magnesium, which it is trying to kick out. So I'm going to look for zinc, and zinc is right here, and it is trying to kick out magnesium, which is higher up on the activity series. So this also will not work because magnesium is higher up, so it wants to be a part of a compound more than zinc does. All right, let's try this one. Do these following reactions occur, and if so, what are their products? So Cu is right here, and it is trying to kick out its like, which would be compared to zinc or nitrate, it would be zinc because zinc is a metal and copper is a metal. So we're going to look for zinc, and zinc is up here. So zinc is higher than Cu, so you would write no reaction. The reaction will not occur. Okay, the next one, lithium versus sodium. So is lithium higher than sodium? Looking up this, lithium is higher than sodium, so therefore lithium will be able to kick out sodium. So Li will bond with Cl, and then Na will now be kicked out by itself. Looking at this, we've created a new compound in LiCl. Li has a +1 charge, Cl has a -1, so those crisscross and cancel. Na is an element by itself, but it is not a hunk or rift, so we do not need to worry about putting a 2. Okay, so looking at this, this is already balanced, and we are good to go. Okay, and now the last one. If you're looking at Br2, Br is a nonmetal, so it will try to kick out the other nonmetal, which in this case is I. So that's why when we're looking at this side, if I'm looking for Br and I'm like, oh, is it going to try to kick out sodium? And then I look for sodium on this side. Well, it's on a different column, so it's not going to work that way. So as soon as you're trying to look at a different column, you should know, oh, bing, 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 I'm looking at the wrong guy. So Br needs to try to kick out I. Is Br higher than I? Yes, it is. So therefore, the reaction will occur, and Na or Br will kick out I exactly where I is. So it would be NaBr plus I. Now, NaBr is a new compound, and it is an ionic compound, so therefore I have to worry about charges. Na has a +1, Br has a -1, so you crisscross and cancel. And I is a Hunkelberg, so therefore it would have it would be a diatomic molecule, so it would need 2. Now balancing, I have 2 I's on the right, and I need 2 I's on the right, so I'm going to put it 2 in front of here. I have 2 BRs on the left, I need 2 BRs on the right, which makes it here, and now my NAs are balanced. So this would be the balanced reaction for this single replacement reaction. So what you really need to get out of this is that you need it for single replacement reactions. You need to check the activity series to make sure that the reaction actually occurs, and the element by itself has to be higher than the element it is trying to kick out of the compound. If it is not, then you write NR. If it is, then you predict the products. Hopefully you understand, and have a great evening.